Hello guys, so today we're going to try to solve another exercise from Leetcode, exercise 203, which is called remove linked list elements. Actually, I solved a similar exercise. I already solved this one actually, but I want to try it again from scratch. But I got to this exercise because I solved a similar one, which was the remove uh, duplicated elements in a linked list, which you can basically apply the same approach with the difference that you need to have a way to figure out which ones are the duplicates. One way is using hash map, for example, but there's some other ways. So let's try to do this one. So remove. Let's first try to understand the problem. Okay. So remove all elements from a linked list of integers that have a value equals a value target. Okay, so we do have an example which is a linked list of 1, 2, 6, 3, and the value target that we want to remove is 6. So that means that we're going to go to 1, 2, 6, but we want to remove this, then we want 2 to actually point at 3. And then, okay, now we're 4, then we are at 5, we are at 6. Then we remove 6, and this is, and this points to none. No, anyway. So here's the thing. This is, as I understand, this is a singular list, linked list. So that means that we only have a pointer forward. We don't point backwards. So that means that if we're keeping track of only the current value, current node, if we're on 6, we already lost track of 2. So there's no way, if we, at least from what I understand, if we need to keep track of the previous node, so we can, in case we match a value here, we point the previous node to the next node. Okay, so well, first thing I would do here is that I would let's create a dummy this node to act as a head. Yeah. Yeah. And then we would assign dummy next equals to head. This way we have something that points to our head. Yeah. And then I would create a previous assign it to dummy and head, because so we can navigate. So so after this, we can create a loop while current is not none. So okay, so once we're here, So we're at 1, we're at 2, we're 3, we're 6. So 6 is so if current dot value equals val, then we want to assign the previous dot next to dot next. Else, if it's not, then the current equals current dot next. And here we're going to return and then we're going to return the dummy dot next, which actually would point to head. I don't know if I'm forgetting something here, so oh no, so else, so this we're always going to do actually, and else we're going to say that previous equals current and current equals current dot next. This is outside of else. Outside of if else, because this happens either way. And this is our return. Okay, so this seems like it would work. So let's try to implement it. Okay, so first one, create a dummy node. This node equals 0. Okay, dummy dot next equals our head. And then we're going to create a previous dot current equals dummy head. So we get this. Sorry, I kind of jumped ahead here. Take care of this. And we take care of this. So now we're in the loop. So while okay, so this is done. So if we're gonna do if current dot value is val, then previous dot next equals current dot next. Yeah, because then we're saying that in this case, for example, we're saying that the 2 dot next is now equals or 6 dot next. And if it's not equal, so for example, from the 3 it's not equal, then we're just saying that previous equals our current. And whatever happens, we need to say that current equals current dot next. Right? Okay. So take care of this. Take care of this. Take care of this. So now turn down next, which is basically the hat, right? So I think this works. Okay, so this is accepted. All right, yeah, you can see that I gave a couple of tries before. So I was pretty sure that this would accept it. Usually I just run this 3 or 4 times because it's funny because sometimes you get like a 50 faster than 50% and then get a faster than now I got almost 80. So let's talk about the time complexity here. Okay. So the time complexity here is the worst case, and it's O of n, where n is nodes. It's definitely O of n because even if the last one is not the value that we want to replace all the the values in here. And this is actually because our linked list is not sorted. If it's sorted, we may be able to take a different approach. But yeah, and in terms of space, so this is an iterative approach. We're using some space here, which is not a lot. Here, we're basically just keeping track of these two guys here. Yeah, so I don't think we're using any additional space. Yeah, so let's verify. I don't know. No, I don't want to look at this now. Yeah. Yeah, so I want to say van also maybe because this is because we're keeping track of all this. Actually, I want to say constant time. This is constant time because we're just keeping track of these two guys, who's previous and who is the current one. We're not storing the whole thing over more than this was already doing it. Yeah. That's it, guys. I hope this was enjoyable. Maybe for next one, I'll try one of these. Let's see. Cheers.